Hello guys, back here with another video. In this one, I'm going to explain to you integration and introduce to you the reverse power rule. So what is integration? Well, integration is the opposite of taking the derivative of something. So when you take the derivative of something, in this case, it becomes a power less. But when you integrate it, you increase the power by 1. The formula for this is the integral, that's the symbol, of x to the n dx is equal to x to the n plus 1 over n plus 1 plus some constant. So just for reference, let's just write down what differentiation was. So we had d over dx of x to the n is equal to n times x to the n minus 1, right? So, and let's say it was plus some constant, for example, the number 4, right? That's what c is. C is just a constant. So in the bottom one, you see, the top one and the bottom one, they're the opposite of each other. So in the bottom one, in the derivative, you multiply by n, right? But in the integral, you divide by n plus 1, because usually the n on the top would be subtracted by 1, right? So you want to add 1, and then you want to divide it by that to cancel out this operation, right? And then the plus c is because we're assuming there is some constant added on, but in differentiation, the constant would just be 0. So we're going to account for it here, and there are ways you can solve for the constant, as I'll show you in the later videos. So this actually right here, this right here is the reverse power rule. So let me write it here as well. It's just x to the n dx is equal to x to the n plus 1 over n plus 1 plus c, right? So basically, this is the opposite of the power rule. I mean, as it says it in the name, it's just the reverse of it, right? So let's go into some examples, and I'll show you. So according to our formula, right? So actually, quick note, f prime of x is equal to d over dx of f of x, right? We know that. So the integration of f prime of x dx is equal to f of x, right? So you can imagine if you take if you have, so the integral symbol, and yeah, so the integral symbol, actually, yeah, this should be here. The integral symbol and the derivative, the d over dx, this cancels out. So yeah, this would cancel out. This would just give you f of x, right? Okay, so this one we have, so now we have the integral of f prime of x dx. This is just notation in the first part. I'm not going to follow it through the entire time. Is going to be negative 14 over 13 plus 1 times x to the 13 plus 1. So 14, right? We have it right here. We have it right here in our formula. Sorry about that. Fix this. There we go. So we have the pre-existing constant 14 over 13 plus 1 times x to the 14. So we could simplify this further, and we would just have negative x to the 14. So now, if you want to do it just for an experiment to prove to yourself, the derivative of this is just equal to negative 14x to the 13, which is what we had in the first part. So now the integral of this, so f of x, right? I'm going to skip the thing, so I'm just going to write it here. But then you would normally put the integral symbol. be negative 8 over 3 times, oh my bad, divided by, right, negative 5 over 3 plus 1 time multiplied by now x to the negative 5 over 3 plus 1. Okay, so let's simplify this. Why not, right? So negative 5 over 3 plus 3 over 3, right? You got yourself negative 2 over 3, right? So now you got negative 8 over 3. 2 over 3, it was also negative, so negative 3 over 2. Cancel this out. Get negative 8 over 2. Right? Recording cut. So then you're left with, so this would just give you negative 4 times, what did we say it was? X to the negative 2, right? It'd be plus 3, yeah, negative 2 over 3, right? That's what it would be. So then f of x would just be negative 4 x to the negative 2 over 3. All right, here we have f of x. This was going to be easy. 9 over 3 times x to the 3. So what you see is that the denominator and this are just the same thing. Always. So I'll be out here. F of x is negative 22 over negative 13 over 2. Write that better. Negative 13 over 2 plus 1 times x to the negative 13 over 2 plus 1. And now let's do the petty additions. Negative 22, so you have negative 13 over 2 plus 2 over 2. You're going to be getting, sorry, brain fart, negative 11 over 2 times negative 11 over 2, right? Next one, oh, we should cancel these out actually. What am I saying? Next one. So then you get f of x is equal to negative 22. Yeah, let's do it like this. 22 times 2 over negative 11. Cancel these out. And that's that. Times x to the negative 11 over 2. This one, f of x is going to be 8 over times 3 over 8 times x to the 8. That's what you get. Let's write it down anyways. 3 times x to the 8. This one, so you have negative 11 over negative 12 plus 1, right? Times x to the negative 12 plus 1. What does that give you? It gives you negative 11 over negative 11. Cancels that out. X to the negative 11. Right? You see how when it was differentiated from the original function, which would be this, it was dropped down a power. It was decreased. It went more into the negatives, right? But when you integrated it, it became more positive. And something that you would want to add is the plus c term in all of these. Here, you don't know how to solve for it, so it might save you the time, but in more complex problems, you definitely want to be adding the plus c. This one, f of x is equal to, going to be 15 over 5, because this is your n, and you need to do n plus 1, right? X to the 5 gives you 3. F of x is going to be 12 over 6 times x to the 6. f of x will be negative 3 over 3 x to the 3. So negative plus c plus c plus c. Now, this one, negative 60 over 15. Oh, sorry, x to the 15 plus c. So give you negative 4. 4 x to the 15 plus c. So as you see, in all these examples, we took the exponent, added 1 to it. So then it became x to the 15. Then we took whatever constant was there. We already put it here again, but we just divided it by the n plus 1, 15. And that's your answer. That is your reverse power rule. And if you want to prove it to yourself, here's an easy way. Let's say your f of x is 2x plus 3. No, let's not say 2x. Let's say x squared plus 3, okay? Take the derivative of this. F prime of x will be 2x plus 0, right? Now integrate f prime of x, right? So it's going to be the integration of 2x, right? We're in a real world example, this 0 would not be carried over, right? You just write 2x. Don't forget the dx. So then this would just give you what? Using that rule, it would give you 2x squared over 2. But there was a constant here, remember? So that's why we add the plus c. So if we're given the initial conditions, then we can solve for that c. But since we don't know, we just assume there is, so we do plus c. Have a good night, guys, and enjoy your holidays.